We're going to begin by looking at valence electrons. This should be a review. So valence electrons are electrons found in the outermost energy level. So if you look at this Bohr diagram here, this electron right here would be a valence electron. It's located in the outermost energy level. These other two electrons that you see here are inner electrons. So again, when we talk about valence electrons, we're talking about electrons in the outermost energy level. Okay? And then if you recall, the number of valence electrons are equal to the main group number on the periodic table. So let's look at this example. All elements in group 1A have one valence electron. So if you look at sodium, sodium is in group 1A on the periodic table. It has one valence electron. For the electron configuration of sodium, if you look here on the right, we've got it all written out. That final energy level, the 3s1, has one electron. That's the one valence electron that we're referring to. All right, let's talk about charge. Charge depends on the number of electrons gained or lost to follow the octet rule. Remember, 8 is that magic number that we want to get to. Okay, and we had two rules that we were talking about. If you had between 1 and 4 valence electrons, you're going to lose those electrons. You're going to shed that outer layer so that you have a full layer of valence electrons below that. If you have between 4 and 7 valence electrons, you're going to gain the electrons that you need to reach 8. So in our first example, we have sodium. Sodium is a group 1A element. It has one valence electron. It's going to lose one valence electron. And when it loses that one valence electron, we now have one more proton than electrons. So our charge would be +1. In the second example, same thing. Potassium is in group 1A. It has one valence electron. So we're going to lose that valence electron. And just like with sodium, we're going to end up with one more proton than electrons. So our charge would be +1. For the third example, magnesium is in group 2A. It has two valence electrons. It's going to lose both of those valence electrons, just like with the previous two examples. Now, because it's losing two electrons, it now has two more protons than electrons. So it's going to end up with a charge of +2. All right, in our final example here, fluorine. Fluorine is in group 7A. It has 7 valence electrons. So because it falls into that second rule, it's got between 4 and 7 valence electrons. It's going to gain one electron to get to 8. Because it's picking up an additional electron, it now has one more electron than proton, so it's going to have a charge of -1. All right, let's do some practice. So for the first one here, we've got chlorine. Chlorine has 7 valence electrons. It's going to gain one electron because it's following that second rule. It has between 4 and 7. So its ion with a charge would be -1. Okay, barium. Barium is in group 2A. It has 2 valence electrons. Because it has 2 valence electrons, it's going to lose those electrons. Remember, anything between 1 and 4, we are losing. Its ion is going to be Ba. Because it's losing 2 electrons, it now has 2 more protons than electrons, so its charge is going to be +2. All right, in the third example, we have oxygen. Oxygen is in group 6A. It has 6 valence electrons. Because it has 6 valence electrons, it is going to need to gain 2 to get to that magic number of 8. Because it is gaining 2 electrons, it now has 2 more electrons than protons, so its charge is going to be -2. Okay, when we talk about Lewis structures, we kind of went through these rules already. If you have between 1 and 4 valence electrons, you're going to lose electrons, you have 0 dots. You have between 4 and 7 valence electrons, you're going to gain electrons, so that you have a total of 8 dots. Ions are going to go in brackets with the charge outside of the brackets, okay? So this is the charge that we're talking about. So if we have a charge, you've got to have brackets. So let's do some practice. So for the first example, we have rubidium. Rubidium has 1 valence electron because it's in group 1A. When we draw the atom with our single valence electron, it's just going to have 1 dot. Now, because it's in that first falls into that first rule, it has between 1 and 4 valence electrons. It's going to lose those electrons. It's going to shed those. So it's going to have a charge of +1 because it's losing that valence electron. And when we write out the ion, it's given away all of its valence electrons. So we're going to just write the name in brackets with a positive or a +1. All right, aluminum. Aluminum is in group 3A. It has 3 valence electrons. When we go to write out the atom, it's going to be Al, and we're going to have 3 dots. When we draw our Lewis structures, we want to make sure that each side has a single dot before we go back and start to double them up. Okay, so aluminum would fall into that first rule. It has between 1 and 4 valence electrons, so it's going to lose. So it's going to end up with a charge of +3 because it's losing those valence electrons. Just like the first example, our symbol is going to go on the inside, aluminum, and then on the outside is going to go the charge, +3. All right, phosphorus. Phosphorus is in group 5A, so it has 5 valence electrons. When we go to write the symbol for the atom, it's going to be P, and we are going to have 5 dots. Following our rules, we're going to make sure that each side gets 1 dot before we go back and start to double them up. Phosphorus is in that second rule. It has between 4 and 7, so it's going to gain electrons to 8. So it's going to gain 3 electrons to get to a total of 8. So when we write out our symbol, because it's gaining electrons, we're going to have a total of 8 dots here. And then the charge is going to go on the outside. Let's do 2 more examples here. We have strontium and bromine. Strontium, Sr, is in group 2A. It has 2 valence electrons. When we draw the atom out, it's going to look just like this. It's going to have 2 dots. Strontium would follow the first rule. It has between 1 and 4 valence electrons, so it's going to lose those electrons. Its charge is going to be +2 because it now has 2 more protons than electrons. When we draw out our ion, it's going to be Sr because it's losing electrons. There aren't going to be any dots. And then our charge is going to go on the outside. Bromine is in group 7A, so it has 7 valence electrons. We draw out our atom, it's going to look just like this. Okay. Bromine only needs 1 more electron, so it's going to pick up an additional electron. It's going to have a charge of -1. And then when we draw out our ion, it's going to have a total of 8 dots. And then our charge will go on the outside. And that was a quick recap of valence electrons, charge, and Lewis diagrams.